Hi guys, my name is Mr. Ben and I am a physics teacher. I am going to be walking you through some questions and a bit of theory about pressure related to the IGCSE or GCSE course for grade 10, grade 11. So first of all, looking at the syllabus points, we're going to be looking at 1.8 pressure, recalling and using the equations P equals F over A and relating that pressure to force and area using appropriate examples. So let's first have a look at the equation before we get onto this example. So the equation is pressure, or P, equals force over area. Okay. Now pressure's units are in pascals. Okay. After the guy who invented pressure, or discovered it if you like, or probably felt it. And the most common units of pascals are actually kilopascals, but today in our examples we're also going to be working in megapascals, okay, which are millions of pascals, where kilopascals are in thousands of pascals. Alright, so it's important to understand those units. When it comes to the units of force, remember the units of force are newtons, after Sir Isaac Newton himself. And another way of thinking about force, if you remember, force equals ma, Newton's second law, and where the mass is in kilograms, so the SI units are kilograms there, I'll put them in brackets, the units. And the acceleration, in our case, because we're on Earth, the acceleration due to the gravity on Earth is in meters a second squared. Okay, so that you could say meters per second. Okay, you could say meters per second squared, or you could even say, if you want to be really clever, meters per second to the minus 2. They all mean the same thing. All right, so when we're looking at force, just remember whatever the mass is in kilograms. For example, if I was 100 kilograms, which I'm not quite, but I wish I was, a couple more months in the gym I might be, after 100 kilograms, if I'm 100 kilograms and we're on Earth, we times it by 9.8, but in the GCSE you can also use 10, okay, meters a second squared, just because it is very close to 10 and it's easier to work out. So my force due to gravity on Earth is 100 times 10, which is 1,000 newtons. Okay, so it's important to understand force before you start working with pressure, and then it's also important to start understanding area. Sorry, the units of area are meters squared. Okay, so if we're looking here, we're looking at meters squared. Okay, so if, like today, we're doing examples where for example, we're looking at 1 centimeter squared, well, in regards to meters squared, that is quite different. Okay, it's actually 0.0001 meters squared. All right, and if we were looking at, for example, 100 centimeters squared, which is going to be the size of our elephant foot, that would be 0.01 meters squared. You see how the decimal place moves twice across there, so it'll actually be 0.01. All right, so important to know that. Maybe go back and refresh yourself with a bit of math to actually be able to convert centimeters to meters. We don't have time to do that at the moment, but you are going to need to have to do that for GCSE. Okay, so let's have a look at this question. All right, just imagine for a second it was a pretty bad day for you, and you were walking around. Let's just say you're in Africa, so that it kind of fits, and you basically saw a lady, maybe a very pretty lady, and she came over to talk to you, and you were both looking at elephants, and she accidentally trod on your foot. Okay, so let's just say that this lady is 60 kilograms. Okay, she trod on your foot. Okay, with one of her stilettos, just the base of the stiletto, okay, so just that part there, okay, and we will say that that stiletto was 1 centimeter squared in its area, all right, and remember she has 2 feet, so the other foot is firmly on the ground, okay, so the pressure is going to be halved. You can do that at the end, or you can even do it at the beginning and just half the weight. And then let's have a look at this next problem. So that's happened, you're in a lot of pain, you're crying out, you probably need an ambulance or to be airlifted to the hospital. But let's just say while you're waiting to be airlifted, the elephant comes over, sees that you're in distress, tries to help, and ends up treading on you. Okay, and let's say that his foot is 100 centimeters squared, and we'll also say that the elephant weighs 3,000 kilograms, okay? And don't forget that elephants have, you guessed it, 4 feet, so there is going to be a distribution of his weight being divided by 4 as well. All right, so there are different ways you can do this problem, but why don't you stop the video now and answer the question, which one would you rather have? This lady, which is 60 kilograms, treading on your foot, or this elephant, which is 3,000 kilograms, treading on your foot. See if you can work out the different pressures and choose what you would rather have. Okay, so let's have a look at how we work this out. I'll just write the equation again. So pressure equals force over area. Okay, so that is our equation, and we're going to start with the lady. All right, so when it comes to the lady, we've said that she's 60 kilograms, but don't remember that is her mass, that's not her force. So what we need to do is we need to say 60 kilograms times the acceleration due to gravity. Remember, F equals ma in this case, and because we're on Earth, it's 10 meters a second squared. So actually, her force is 60 times 10, which equals 600 newtons. Okay. Now, looking at her area, we have already said that it's 1 centimeter squared. Okay, so in meters squared, that is going to be 0.0001 meters squared. Okay, so we've got our newtons over meters squared, which is the same as our pascals, and we put that in the calculator. So 600 divided by 0.0001, and we should get 6, let's write it down the bottom here, we should get 6 million pascals. Okay, so it should equal 6 mega or million pascals. But you remember how I said the weight's distributed by 2 feet? So actually we're going to divide that in 2, which means that really the weight of just one stiletto and really just a corner, or that 1 centimeter squared, assuming that she's not making contact with the ground, is going to be 3 megapascals of pain onto your foot. All right, so that is the amount of pressure this lady with stilettos is putting on your foot. All right, let's have a look at what the elephant does as far as damage. Okay, so the pressure in this case is going to be, remember, the force equals the mass times acceleration, so 3,000 times 10, which is going to be 30,000, or probably because we're working with newtons here, let's just say 30 kilonewtons, okay? And then the area is 100 centimeters squared, so that is the same as 0.01 meters squared. And using our calculator, okay, 30,000 divided by 0.01, or if you're very good at maths, you should work out that that works out to be 3 million pascals, okay, which is not our final answer. Can you guess why? Because elephants have 4 legs. Okay, so we're going to divide it by 4, and that is going to give us 0.75 megapascals. Okay, another way of putting that could also be 750 kilopascals, but let's keep them both megapascals because we're making a comparison. So, to answer the question, the person that I would prefer to tread on my foot would actually be the elephant and not the lady. All right, because as you can see there, it is 4 times. Whoops, what happened there? It is 4 times less than the lady's 3 megapascals. All right, so there we go. We've solved a problem there. Good luck trying to work out your own problems. And remember, for those who've got GCSEs coming up, try not to feel too much pressure.